All right, boys. Yes, please don't. Don't. I tell you what. Don't introduce me to the idea of fucking anything at this point. All right. Let's do some fucking Navis Stokes fluid simulation again, boys. Hey. All right. I have an idea. Just so goddamn crazy, it might work. Okay. We are introducing a brand spanking new type of content. All right. The offline chats. I tell you what, there's absolutely no pressure to be on a stream or anything. To be fair, I could just hit the go live button and just kind of ignore the fact that I'm streaming, but we'll start out like this. Alright. No chat, no nothing. We're gonna upgrade the Discord to, I think you can do stages in Discord, can't you? I think that's a thing now, no? Because it's kind of like what we're doing right now, but on a larger scale so that anyone can raise their hand and come in. But, yeah. Yeah, so I think we just have a constant stage running, and I just sit here offline and we'll just solve the problem. Because the whole concept of like going live, like going on stream, I only do it for 1.5 hours, and it's kind of like high stakes. I've always got to be doing something. But this is going to be a much more relaxed, I can fucking just literally... what do we want this segment to be called? All right. Offline something. What flows with offline? Yeah, let's just throw a random word at the end of it, bro. A hotline. Okay. That makes sense. I thought you said hot wine. I'm like, we in like mulled wine? What is this? Offline hotline. Offline hotline. Alright, let's hop in. Welcome to Stages. You might be muted unless you're invited to speak. You can leave and rejoin anytime we're making a noise. Request to speak, join the conversation. Start the stage. Okay. Stage topic. No. Fuck you. Balls. The stage is already open. Alright. How the fuck do I... Wait. Alright, there we go. Hang on. We need to rename... How the fuck are so many people just jumping in? Alright, amen. Hang on. We have to change... We have to change the stage topic to something a little bit more appropriate. There we go. Do people get just notified for this, or is it just something randomly that's happened? Okay, word. All right. Oh no. Oh well. She'll be right. And let's No. Alright, we got Dark Ninja back up here. Alright, hang on, let's just keep it on like members or something. Okay, yeah, well that's perfect then. The Offline Hotline, a brand spanking new segment for Randy.gg members and everyone else who joined before it was changed to members. That's okay though. You guys can chill here. I don't know. So basically what's going on here is I'm just going to sit here and program offline with absolutely no pressure. I can kind of take a break whenever the fuck I want. I can leave for 2 hours at a time and kind of just come back and chill. And you guys can, I don't know, come up and help me out if you want, but That's literally the goal. The goal for today is to get fucking physics planned out and sorted and being well on my way. Because the issue I have at the moment is that every day I only put in about 1.5 hours worth of work, which is pussy shit, you know? I want to be able to put in more work, but at the same time, it's like, why do it offline? But why not do it offline, you know? So, there we go. Bada bing, bada boom. Time to create physics. Yeah. Yeah. Okay, cool. Hang on, where is it? Okay. Chat. Oh, coding my valid integration, okay. Right. That would be nice, yeah. Okay. Ah well. Sure. We're chilling. Hell yeah. Alright, well, I guess my first step is to actually define all the different cases that I need for, for collision. Clearly define the cases I want to solve for. So I'm literally just gonna boot open Milton. Not Milton. I keep calling it fucking Milton. What is it? Leonardo. I'm gonna open up a new file and go. Physics constraints. Let's see. You know, there's no way of doing video in here either. Yeah, I feel like surely video would be the play. Ah, okay, yeah, there's like a notification in the top right. It says use server default or nothing. I don't know what that is, but maybe it's in the settings. Yeah, right. Yeah, I really wish stages would have had video. I was kind of counting on that. But, oh well. It is now just a voice hotline. Oh well. Yeah. Yeah. FAQ, can I do video screen share in a stage channel? No, this time stage channels are for audio only. Alright. Word. Well, it kind of makes sense because stage channels can currently support up to 1,000 people at once. So, I feel like they've got that limitation in there for a reason. That is true. Yeah. Alright, well. I will narrate what I'm doing. I could also literally just go live. Yeah. Yeah, ping would probably be the best idea. Yeah, I mean, yeah, see you later. Thank you. Alright, so what I'm going to do is I'm literally just going to paint out all the different constraints that I need and like just paint out a full picture of what I want to happen with the physics system. And then we can kind of just take it from there, I guess, and run with it. That's what I was thinking. Like I should literally just hit the go live button and just kind of like, hang on, I can change the title to. Yeah, may as well just fucking open it up. Like that really matters. If someone has like a really banging idea, then they can just type in shit chat or whatever. We'll figure it out. Should be live. That way you guys can see my screen. Yay. A nice little workaround for the fact that Stages doesn't allow for screen sharing. Alright, well, yeah. I feel like I'm literally gonna chill here. Just keep the stream running. And then whenever I need to have a break, I'll just leave. And then whenever I feel like working on the problem, I'll come back in and kind of just chill. That feels like a good solution. Yeah, I'm just gonna literally keep this running 24/7. I tell you what, by the end of today, I would like to have a general idea and a definitely actionable step for the physics engine rework, whatever we're calling it, refactor. So I guess the first thing I need to do is actually boot this guy open and start drawing out what I need. Alrighty. Oh no. Okay, so I'm just gonna mute myself as well. I'm deafen. Adios. Am I deafened? I'm deafened. Cool. Alright. Blank slate. Blank slate. Let's see. Alrighty. So we've got some ground. So number one. And let me smooth. Number one. Yeah, let's draw that one properly. So, number one. First things first, what I would like to do is basically this entire thing. I would like this, so these are really just a bunch of little ground segments, so we can just kind of like paint out the vertices here. Alright. So all of this, I would like our boy Ronald to just run through this with a constant speed with ease. And with kind of just, I'd like our boy to run through this with a constant speed, which is kind of what's happening at the moment, and not really be affected by the fact that any of this is a slope. Like this slope is so minuscule that we don't want to apply any resistance to the player. So for example, if he were to be right here, you know, this angle is obviously a bit more steeper than this angle. We still want him to be moving at exactly the same velocity, right? Just for sake of cleanliness. So that's constraint number one. And then constraint number two, and let's just do this. Constant V. Right. Should also probably server deafen instead of me doing it manually, so you can undeafen me if you ever need to interject. Nope, that's manual. I don't think you can even server deafen. There we go. You just put me in the audience. Yeah. I don't think you can force someone up to this stage though. That's actually a good point. You guys can just mute, yeah. Solution. Problem solved. Alrighty. So, that is constraint number 1. Constraint number 2, we'll pick a nice color. Nice different color for this guy. Number 2 would be... let's see. We'll keep things simple for the time being. And... so ideally... ideally we have number 2 and... and this is not smooth anymore, you dumb bitch. How dare you? And then we'd call this something like 0.5, right? Why do I keep just writing 5s horribly? So it would be at some point, alright, so we've got this angle. Jesus Christ, okay. That angle and this angle. Ideally, you would then dynamically slow the velocity, right? So this would still be 100. Say that the velocity is 100, right? This would still be 100, but then at this point, you would then get down to something like 20 or something like that, right? So 100 to 20, and then as soon as it gets to 20, as soon as it gets beyond 20, then you stop, and you can't, and you can no longer climb up with it. Just be 1.5, not 0.5. But we're just gonna ignore that for the time being. I actually have no idea how to change that, but that's okay. Is there a hotkey for smooth? Surely. I give a fuck. So, we can ignore that, and we can literally just say, as soon as it hits the max angle, it can we'll just say just stops. Stop. Yeah. Yeah, so I'm literally just taking this upper bound and just clamping that. No, because I want to carry on. Like I'm eventually going to come back to this, but we're just going to carry on to like number 3. So we're just going to skip over this step for the time being. But it is a yeah. Alrighty. So number 2, as soon as it hits a certain angle, right? Which we'll call, I don't know, we'll just say like 45 degrees. You can no longer go up with it, right? Or more specifically, it's not stop, it's can no longer accelerate. So we would have kind of a concept of just some kind of variable where it's like does have footing. Something like that, right? It's basically saying, am I able to continue walking like this? And now, if it's on 45, sorry, go. Alright. Gotcha. Hit it. Or it's gradient, or yeah. Yep. Mm-hmm. I don't think I understand you too well. Mm-hmm. Yeah. He's moving along. Yeah. Yep. Ah, I see. Yeah. So you would essentially, just angle it parallel to the ground, depending on the slope. That's actually a very good solution. Yeah. Yeah. I mean, you could do that. That kind of just feeds into the implementation of this, but yeah, I'll have to do a bit more thinking about that once we do move on to it. But I'm just going to keep fleshing out the problems, and then we'll come back to that. Alrighty. So back to this does have footing. We could basically, just so I remember this actually. Just gonna do that. Alright, so if it does have footing, which is defined by, it's got this angle, we're moving along. If the angle's too great, it no longer has footing. If he's in the air, he doesn't have footing. He only has solid footing if he is on solid ground and he's chilling, alright? He's vibing, which is cool. So then, let's see. Alright, so we're not going to make this 45. We're going to be like, alright, if it's greater than greater than 45 degrees, he can no longer accelerate. So if it was like 46, right, or something like 60, then what would happen? He would run up, has footing, no longer has footing, but he still has velocity, so he's still climbing. But then eventually he runs out of velocity and then slides back down. So that right there is number 3. I'm actually going to redo this in a different color. So constraint, or I don't know, constraint. I don't know if that's the best way of putting it. Like problem 3, I don't know. Constraint, may as well. Alright, so if we're at 60 degrees, and our boy is running. The best stick figure you will ever see. Alright. Eventually he'll hit a point where the velocity just runs out. So it goes from 100 all the way down to 0. And then because there's gravity, it'll actually just start slipping back down. So then he will 0 down to negative 100 or whatever the fuck I'm doing, right? And then he will eventually just slide back down to here. Amazing. That's such a complicated diagram, but I guess you kind of get the gist of it. Is he'll eventually just say slide down steep slopes, but everything less than or equal to 45 degrees, he can literally just stop moving and he will just stand there like a champ. Stays put. Right? So he's chilling. He's vibing. Now, I think this, of all of them, is going to be the hardest thing to do. Like, we're kind of doing it at the moment, but it's because of a bunch of, like, weird... It's got friction, but the friction is dynamic friction, and it's like, do we really need dynamic friction? No, it's static friction. It's just like a whole thing. But it's basically what's happening is the friction at some point, because of this angle, the force of gravity exceeds the force of friction. That's pretty much what's happening here. So gravity, or what would you say? Yeah, I don't really know how that gets defined, but just for all intents and purposes, the gravity is greater than the friction. I think that's how it would be modeled. I'm not too sure, but let's just say that it is. All right, so 3 problems, technically 4. What is the next problem? So the next problem, we'll say number 4. is the problem of step height. Step height. So, max height. So anything greater than that, the player just hits it and it's a wall. But at any kind of this height, if the max height, yeah, so anything less than this, just auto step. Auto step, he will just magically, he'll magically just be walking along and it's like, boop, and then he steps up. Alright. Like the hit movie, Step Up. I didn't even put a thing in there. Step Up 4, baby. The best one. Is it? Is there even 4? I guess we'll never know. So he'll auto step, and then that'll be all chill, and he'll just carry on. At some point, though, actually, oh, okay. So here's an idea. Idea time. Let's go back to this. Give me the color. Give me what color? Thank you. Oh yeah. So what we could do. All right. This is a little bit cheeky. All right. This is a little bit cheeky. I'm gonna change this. This problem to just be number 4. Auto step. Now, it's not really just a step, right? So this kind of goes a bit into, I hate how the fucking smooth gets escaped before the, oh well. Minor details. So we'll say that this right here, anywhere from there all the way up to here. So, min, max. And this will determine the step time. Step time. Right? And then the step time will basically determine what it does, right? So this right here is just kind of like a shrug kind of auto step. Yeah. Kind of, but we really want to interject and do something else, because at a certain point, right, like this guy all the way up until this point right here is really an auto step. So we don't really do anything beyond that. But as soon as it hits this max right here, this max bound, it then goes up into climb mode. So you would basically put your hands up and like vault over it, like push up over it. And yeah. So we could say something like this is the scale. Yeah. That's the scale right there. So then at this point, you would vault, right? No. So then anything up here would just be like, would just say like vault. And then anything in between, that'll I guess we don't even really need to interpolate. It'd just be like 1 or 0, like step or vault, and then we play out the vault animation and you kind of just up over it. And then we can kind of take that to an extreme, and then that is like the climbing system. But that's like next level. So beyond that, grab this color. Number 8. Number 8? What the fuck? Yes. Why do I... Yeah. I'm not too sure. Yeah, I really don't know. I think the sphere should probably just kind of automatically just raise it up, but it depends. Like as soon as it hits a level that's too big, it's gonna shed some velocity. So I think we kind of just need to step in and write a statement for that, like just a constraint. But yeah. Anyway, so number 5. What the fuck? What are you doing? Okay. Number 5. I don't know why I keep writing the 5s like they're 3s like that. That's so strange. Anyway. 5. Climb. So this is kind of going a bit beyond the entire physics system, but we may as well put it in here because it is kind of necessary. Actually, no. So, what did I say this was? 60 degrees. So anything beyond 60, you slide down. But we could even go like back like this even. Just for simplicity's sake, we'll just do vertical and we'll kind of keep it like that. So now it's kind of beyond that max vault height, right? So if it's beyond the max vault height, max vault, then we kind of switch into the climbing system, right? And it's also a case of yeah, because there's kind of like a tricky in between thing here where it's like if he climbs up or if he runs up and he makes it up to here and that continues on like that, then you know he'll obviously just kind of like run over. But maybe we could have something where say he's like this far, he could technically still grab onto that ledge and kind of like drag himself up, but that's kind of getting a little bit beyond into overcomplication territory right there. So So I tell you what we can actually do with this. With these two down here, so this color right here equal not physics. Yep. So you can also climb slopes. So it depends. So as soon as you unlock the ability to climb, then that's when anything greater than what did we say, about 60 degrees, you then just go into climbing mode. So we're going to ignore this for the time being because this doesn't really have anything to do with the physics system. It's more like just a constraint where it just flips into a completely different mode. So we can actually ignore that, and it's really not physics. But everything else is physics. So we can ignore the vault. That's not physics either. The auto step, we can just kind of like hardcode in, and then that's kind of like just like a neat little constraint that we can put in. But all of these, I'm probably missing something, but those are the constraints of the physics system. So let me just, let's just do this. Yeah, I think so. How do I... Why is it not letting me go back out? This is really annoying. Yeah. Physics constraints. Strengths. There we go. English. Okay. Let's just pretend that that is a nicely, definitely not wonky title. Physics constraints. Oh, now it's letting me fucking zoom out. I have no idea what that was. Cool. What? Alrighty, so those are the physics constraints that I can think of. Just these guys right here. There's probably some more, but that's the general system. That's kind of what I want to get down pat. That's what I want to support. So the first problem really is, well, I guess just starting from a blank slate. So we'll go into... cool. So clearly define the cases I want to solve for. Done. Yeah, I mean, that's all I can really think of at the moment. I might be missing something, but at the same time, I think it should be pretty good. Yeah. Let's see how we go. We shall see how we go. So really, the first step of any good rework is, of course, to eat the entire goddamn thing. Goodbye. F in chat for the current physics system. Now would probably be a good time to put in some kind of quad tree, but I don't know, probably not. What do you mean? Ah, gotcha. That's a good point. I kind of do need to practice that a bit more. Bring it back. So what I'm gonna do... Actually, it would be so much better. So much cozier. Alright, source tree, give me your power. To get GUI. Hell yeah. Alright, I tell you what I'm gonna do. Just before, real quick. Hell yeah. Amen, brother. Okay. So. Old physics. Clean slate. Alright, so I'm just going to push that up. No, I haven't. I'm just going to keep old physics. Yeet. Alrighty. So now, what I do is go branch, new branch, physics, rework. Boop. Alrighty. So we're now in the physics rework branch. And what I'm going to do... I don't know if I kind of want this here, you know? I kind of want to reference it a little bit. So I think what I might do is... Tell you what. Plonk it in a text file. I'm also just gonna get rid of this. Yeah, literally just the entire fucking thing. Goodbye. There we go. Lovely, awesome, exactly what I need. This now has white space. I probably shouldn't put it in a text file. I'm actually going to put it in. I'm gonna see. Cool. Lovely. Exactly. Okay. So that's there. Got a clean slate for the physics. That is lovely. I actually don't know why I'm marking this. I'm trying to think. Could this be edited into a video, or should this just go to the wind? Maybe put it up on the archive channel. That could be an idea. Yeah, that's an idea. I mean, that's fine. That's just part of the process, you know. All right, we're gonna put this up on the archive channel. Woo! People who want to watch the entire fucking thing, which is hardly anyone. Just a few of you goddamn freaks. I'm talking to you right now. That's right. Why are you watching this entire thing? Comment down below with the exact timestamp to prove that you're watching this entire goddamn thing. And if you are, I'll give you a gold sticker for wasting your time. Man's game in the system. Alright. Let's see. Yeet entire system and rebuild. I don't know what you mean by that. Right. That is definitely a thing. So that was the next thing that I want to kind of address in this branch is kind of figuring out. So we'll go to the Datadesk file, and then we'll go down to a to-do. No callbacks, good. Lovely. Comb over this fuck and maybe do a bit of house cleaning. Yes, sir. So everything is inside this physics body data struct. Now, the problem is that the entire game world, I think it's, yeah. So the entire game world is being serialized. And we've got trees and stuff in here. And if I change this, then that's going to fuck up the serialization. Because, you know, that's just how it be. Because I'm a fucking dumb shitter that doesn't know how to do serialization nicely. What do you mean? No, this is my own megastruct. But like, the entire concept of an entity. So inside this entity, we now have the physics body data. But if I alter this physics body data, oh, so right, what you're saying is I don't need to change anything. Yeah. Yeah, so it's like, maybe, but at the same time, I have some, like, this is from the Qt C2 single header library. So I've got some stuff in here that are a little bit iffy, and I think I could maybe clean it up, but I'm not too sure at the same time. Yep. I think that's what it is. Yeah. Something like that. Actually, I think I kind of ran into this issue. I don't know. I think what I need to do is yeet this as well and start it from the fucking ground up. So let's figure out exactly what I need. All right, so that's another whole issue. Is, well, obviously I can't run around anymore because we don't have any more physics. But let's kind of picture how acceleration works. Like, obviously, as soon as you hit the A key, you shouldn't be going at max. It should relatively ramp up, and that ramping up right there. So going from 0 to, let's say, 100, which is the speed at which you want to go, velocity-wise, if you're running. That right there, I would really like to model that with a curve, with some sort of curve, instead of leaving it up to the whims of the physics simulation. Yeah, basically. But yeah, I don't know how to get that into the physics. Like, I don't know how to. Yeah, that's what I mean. Like, that's what I'm currently doing now, is I'm applying a force in order to move the character. But it feels like that's an extra step that's going a bit. Yeah. 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 So I was thinking, like, you could just set the velocity directly based off of that, and it would just be a curve based off t, which is, you know, like how long you press the button. So we could have that, but yeah, because right now I believe it's being set via force. So if we look at, I'm actually going to bring in the physics real quick. Just kind of keep that in there for now. If we look at the player, it's a little bit disgusting, but bear with me. Yeah. Yeah, and the thing is, it's being done with a force right here, and that force dot x is equal to the character access times it by some fucking weird shit going on with mass, and it just, all right, I think that's to cancel out the mass. I'm not too sure, but yeah, I honestly just have no clue what's going on here. Yeah, me neither. Me neither. Yeah. Yeah. It's also just, I think the reason I did that is so I could normalize the whole idea, or just get rid of the concept of mass, but I don't like on the force. But you know, we can just ignore that because it's all gonna get fucking yeeted in 10 seconds flat. So basically, what we could do is directly map the velocity to the time that you've held the button down for, which would make sense. It should be a really good way of doing it, because then you have full control of it. That'll be very easy. Yep. Yeah, yeah, and that's the only issue there, is how those two interact. So yeah, yeah, yeah. Like that's what we'll just do to begin with. Just a nice, easy way of popping it in. Yeah, 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 and yeah, yeah. Now, the reason I use force instead of velocity is because how the impulse resolution works is it works through velocity. So it adds velocity to resolve the impulse. So that's why I didn't override that. Yeah. Yeah. Sure. So, the next question is, do we do impulse resolution again? Or what was the alternative? Discrete? Whatever it's called? Also, with the jump, we need to override the physics and not actually have that physics base. So that's kind of like another constraint, because just having like a physical jump, like yes, it's accurate, but it feels a lot better to take over and do jumps differently. I watched a GDC talk on that the other day, so. I'm pretty sure it'll just be instant. Like, do no harm to input. Yeah. Yeah, but I think what I meant by this is, as you're falling, the velocity should actually just, like, we just kind of scrap the idea of gravity, and we just kind of take over and just, so it goes up, and then it falls down a lot faster, I think is what the verdict was, because it just feels better. Yeah. I think so, yeah. I'll have to go back and watch the talk, but yeah. Yep. Yep. Yeah. And it's like, how do we override that behavior? That's true. But you could also, like, you could also have the entire height of the jump mapped out to a function. So instead of even putting velocity in it, but then that feels a bit rough. What if something goes wrong? That's true, yeah. 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 I think the solution here is to not worry about that problem yet, because it isn't here. Exactamundo. Wow, already done. Amen. Don't you just wish sometimes implementing a big system, you're like, wow, I just wish I could copy and paste some code, but exactly. Yeah. So, in essence, Your Honor, yeetus deletus. Perfect. And we're also gonna go back. Alright, so, before I do that, I actually need to update this, because if I change anything in the physics body data, then the game is not going to load. So, solution, I could get rid of the trees, since that is really the only entity being serialized. Because I would like to eat this and kind of do it from the ground up again. But yeah, if I eat this right here, well, shit's gonna stop compiling, I think. But maybe if we do something like that. Nope. Needs collide against. Alright, so let's get rid of something. Gravity multiplier. Surely. Nope. Okay. Yeah, it's just referenced everywhere. So I'm just gonna eat the rest of this. Yeah. Going to mute myself. All right, physics. Like I would like to get rid of this and do it again, because it feels icky. It feels icky. I don't want it. Because, you know, I feel like I can't make changes to this entity because I'm just scared to break things. So, solution. Solution is I preserve this in time. No. Version 0. Surely we do this. And then all was good. Nice. Nice. Now, if I change any of this, for example, we get rid of something like that. Harmless, right? Harmless. Absolutely. It's definitely not harmless. This is an interaction. Cool. Durability. Yeah, it turns out you need most of this. Alright, let's say we get rid of material. Material definitely gets used, doesn't it? They make me get rid of all of you. I'll fucking do it. I'll do it. And there we go. Things have been broken. So maybe solution here is don't have a map and we just kind of get rid of these guys. That doesn't feel like a very good solution though. I don't know. Goodbye. F in chat for the trees. To be fair, we do kind of have a reference point with this, so we don't really need the trees, so. Peace. It's nice talking to you. But now my question is, how can I... Let's go into the editor. Map, load editor data. Map data. Save map data. We can kind of just get rid of that. We can also get rid of the fact that we load the map data. Eh? Read entity from file. File. Surely. Surely. Yay! Alright, we have been unburdened. Unburdened from the entity. Lovely. Alright, so I fixed the whole entity issue. And now I can change whatever the fuck I want without it dying. Which is good. Oh. 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 Hello. There we go. What's the offline hotline? Lovely. Oh. I don't know why that didn't work. That should have worked. Maybe because I'm on a new computer. No, it definitely came up in the sidebar. It's just Windows didn't give me the notification, which is strange. Yeah, so I've kind of gotten rid of the entities, so should be good. Okay. Now, the one thing I didn't really like about this, but I think it's necessary, is that how I distinguished shapes is I've got a shape here, and that's a C2 shape, and it's a, what's the word? What's the struct, but not a struct? Union. Alright. So it's a union of all the different possible shapes. And then right next to it is stored a type, which is just an enum, which defines what shape it actually is. Just to kind of like pack everything together. Now, I guess that kind of works. Yeah. I would like an alternative because it feels yucky. How dare you? So, yeah. Shape type is an enum of what shape it is. So it could be AABB, capsule, circle, poly, line segments. I think I've scrapped the idea of line segments. I don't know. That's shape. What do you mean? What, the shape type? Oh, alright, yeah, so these come directly from the single header C2 library, which define different shapes. And the way I generate collision information is, yeah, so this is basically how I generate collision information. Is go like C2 circle to ABB, capsule, all this kind of stuff, but, yeah. So that's how that works. I think I keep using C2 because that handles a bunch of the collision stuff that I couldn't be fucked doing. This is Randy Gold stuff. Cute C2. Yeah, deadass. So I'm literally not gonna touch that. So what I'm calling here down at the level is the manifold, and that gives me a manifold, and that basically gives me like the penetration depth and like the normals and all that kind of stuff. Yeah. Yeah. Well, I could just, dump them all in here, megastruct, and type, and just not even use, and just use whichever one I want. But, like, that's just, it feels like a waste of space. It is, yeah. So that's why I've put them into a union. But, and then I just have the actual shape type here, which, I mean, like, it makes sense. I can't really think of an alternative to doing that. Like, it's nice and portable, I guess. So I think I'll just keep that. Now, below that, material. So now I've got another struct called physics material, Which, where the fuck is that? It's in the catch-all, so it's still in Datadesk. Physics material is all the way up here. Great. Density, restitution, static, dynamic friction. Alright, so yeah. So I'm just going to move this around so it's more close. I don't know how this managed to get separated. I really need to switch to using Metadesk, like, I think I'll do that when we get into the new version of the engine. Alrighty, so I'm just basically going to material. Alright, so I don't know why I separated out material. Like, is there a reason for that? I'm not even using material anywhere in here. Alright, it would have been in the physics. Yeah, I really don't know why I did that, so we're just gonna kind of leave that for the time being, and I'll put in whatever I need. So we'll kind of just keep that commented out. Yeah, just literally one friction. So let's keep friction. Alright, so next up, mass data. Again, why is this separated out? I think this is just, you know... You know, but like the fact that mass data is separated, like why isn't this just in here? But yeah, the fact that I've inversed this is just for caching it because divisions are expensive. So we'll get rid of that. Yeah, so now we're getting down to this. So velocity and force. Like, what do we need to store? Like, we need velocity. It's like the intermediate. Well, I was putting in force here, and like this force would then get applied to the velocity at the start or at the end, I think. And that's how I was manually moving around the player, was with the force. But if I set the velocity, then the velocity is going to get overridden by the fact that it's doing impulse resolution. So that's kind of why I had it. But I think this might just be a order of operation issue. If anything, like I just put the player in front, so I think we just kind of yeet this and cross that bridge when it comes to it. Yeah. Yeah. Momentum. So what's momentum? Okay. Gotcha. Okay. I think we'll just keep them, just keep it at velocity. I don't know. Like, we'll just keep things simple. What, so as in just literally... Yeah. Yeah, well, that's what I was thinking. But then you can derive momentum from, like, just momentum divided by mass or whatever. And that gives you velocity. Yeah. Yeah. I'm just thinking, like, why bother storing momentum if we can get momentum by just multiplying mass and velocity together whenever we need it? Yeah. Well, I think... How about we literally just cross that bridge when it comes to it, and if we need it, then we'll plug it in. But I'll just put, like, a little to-do here. Alrighty. So type, physics body type flags. I'm going to change to this because it's not really apparent what that means right off the bat. So I'm going to change it to something like physics body flags. I'm literally just going to keep it as flags. Why not? And then we'll change this to flags. And that's how we can sort what we're colliding against, what we are, all that kind of stuff. Like this will give you data. Flags, we could even call it something like properties. Yeah, why not? Why not? Physics body properties. Properties. Collide against props. Change this down to props. Why not? Going full web dev mode. I don't know if we need gravity multiplier. Yeah, maybe one day, but I'm just gonna leave that. So we kind of just move this out. And then we should be good. Alrighty. Well, we'll cross that bridge when we come to it, boys. And just keep it there for now. Physics, body properties, cool. That's probably going to break a bunch of things. Yep. So what I'm going to do... Oh. What else we got? Nothing here. Right, so a bunch of this. A bunch of this. Alright. Pre-move update player. So I think what that refers to is in the world. I do, yeah. Let's see. Yep, so this is pre-move update player. So that means, oh, pre-move, as in pre-physics. That should just be called pre-physics. Oh, so it's not mass, it's force. What? Mm-hmm. Okay. Alright, so in essence, we just put momentum. Yeah. Cool. Alright, sounds good. Alrighty. So next thing I want to do is kind of go over this whole concept of pre-move, pre-physics. Don't know how useful that is, but pre-physics update player. So pre-physics just means it like this gets called before the physics happens, and it's for like updating the player. I don't really know what the fuck I'm doing there, but then it's like post-move update player, and then I'm doing other things in there. I don't know. Yeah. Yeah, and it's applying Yeah. Hmm. Yeah, I mean it's just the way that I've named things, a bit dumb, but um, I feel like that's a first step. Pre-physics and then post-physics. There is definitely a reason to split these out. I mean, they're really just updates on the player, but I don't know. We'll figure it out. Who cares? Who cares? All right, next up, what do we got? Presets. We clear you. More presets. Fuck, this is so much shit. Alrighty. Yay. Alright. So, the first thing is just going to be putting in the physics and actually applying some kind of gravity or something like that. And then we'll take it from there. Cool. I need to go make some lunch. Kinda need to make lunch. 3:30. Need that for MSVC. Alrighty. I'm gonna go cook some lunch. It's gonna take like probably 10-20 minutes. I'm just chucking shit in a pressure cooker. I'll be back in a jiff. I guess you guys can keep the stream entertained. Alright. Do I share screen or something? And I'll just like put it on. If you have anything interesting. Maybe chat can help you out. Walk you through it. You don't have to. I can just leave it like this, but Oh, there you go. There we go. Alright, have fun. Adios. Don't leak anything important. Now this is definitely me sitting behind the screen. I'm not... This isn't someone else. So I'm going to keep the category on. This is definitely software and game development. back at it. Very nice. Calculate tensor. Well, off I go. See you guys later. Top of the morning to you laddies. Oh. Ooh. Hell yeah. Oh, I think it's time to hop into the trance playlist myself. Let's see. That are my glasses. Wait. I do. I have my GigaChat programming glasses. You guys ready to program? Alright. Same thing. Alright. What are we doing? Well, man doesn't move. We want to make man move. How do we do that? With the power of physics. I don't know what the first step is. I do need gravity. Now surely there's a little gravity constant lying around somewhere. Here we go. World gravity 400. Yeah, that was a multiplier. It could be, yeah. True. Yeah, you could just like flip that on as soon as you reach the apex. Or we just have like, yeah, that'd be a multiplier. There we go. There we go. Let's see. Oh no. That requires me to go into Discord and then right click myself and then do that, and it's like, yeah, it's a lot of effort, you know. But I guess I'm deafened now, so goodbye. Alright, what are we doing, boys? What are we doing? Well, first of all, I think we just watched the good old tutorial series. The good old tutorial series. Over here. Why not? Why not? Prerequisites. This article involves very many mathematics and geometry, and to a much less extent, actual codes. Basic understanding of simple vector math. Cringe. Algebraic math. Cringe. Collision detection. Three add two circles, add them together, you check to see some greater distance between the two circles. Amen. What about circle on AABB, huh? It doesn't matter because we're already solving all that. Impulse resolution is a particular type of collision strategy. Collision resolution is the act of taking two objects who are found to be intersecting and modifying them in such a way as to not allow them to remain intersecting. Wow. In general, an object within a physics engine has 3 main degrees of freedom. Movement on the xy plane and rotation. We implicitly restrict rotation, just use A, B's, and circles, so the only degree of freedom we're willing to consider is movement along the xy plane. Facts. By resolving detected collisions, we place a restriction upon movements such that objects cannot remain intersecting one another. The idea behind impulse resolution is to use an impulse, instantaneous change in velocity, to separate objects found colliding. In order to do this, the mass, position, and velocity of each object must be taken into account somehow. We want large objects colliding with small ones to move a little bit during collision and send them to small objects flying away. We also want objects with infinite mass to not move at all. Facts. To achieve such effects and follow along with the natural intuition of how objects behave, we use rigid bodies and a fair bit of math. A rigid body is just a shape defined by the user. That is implicitly defined to be non-deformable. Both AABBs and circles in this article are non-deformable and will be no scratching and stretching allowed. They are rigid bodies. Working with rigid bodies allows for a lot of math and derivations to be heavily simplified. This is why we're objects collided. Now what? Assuming we have found two shapes in the second, has one actually separate the two. Let's assume our collision detection provides us with two important pieces of information: collision normal and penetration depth, which is exactly what we get from these generate collision pairs. But I've commented this out because of reasons. The only reason actually being this. And this. Cool. Alright, so what's happening here is we are essentially just getting a pair, right? Oh, this is just a pair of collisions. So this just fills out a big array of everything that needs to be collided. And then you loop over that array, and one by one you test them against each other. And you go like this against this, and then we give the manifold, and then that manifold. Inside the manifold, what we have is depths and n, which is the normal. Normal and the depth. So that's what we got. In order to apply an impulse to both objects and move them apart, we need to know what direction to push them, by how much collision normal is the direction in which the impulse will be applied. The penetration depth, along with some other things, determines how large of an impulse will be used. This means that the only value needs to solve for is the magnitude of our impulse. And equations are broken. Which is exactly what you want. Cool. Alright, sweet. That's great. Me likey. Yeah, there's no way I'm deciphering this. Yikes. Have a slight problem. The article is broke, yes. We could literally just run with what I've got now and just kind of decipher it and copy it over and try and understand it that way. could. In fact, it would probably make more sense than trying to follow the tutorial again, because that's exactly what I did last time. So, we're going to go over into the old physics.c and just do a little bit of snooping around, eh? A little bit of snooping. So, we're looping over every single physical entity. We are applying gravity. So we've got a multiplier there. What? Oh, nice, nice. Yeah, it's literally just applying gravity. So it's like, don't have mass, and then we're adding force. Yeah, exactly. Yeah. We can just scrap that idea. And then... we could just kind of forget about that. There's no point prematurely doing it though. Yeah. There's no point doing that for now. Alright, so... if entity physics dot mass is not equal to 0, then I'm going to entity physics dot... now, this is where I applied it to the force. So, would I... so do I just store it all in momentum, or? Okay, gotcha. So then we go world gravity. Just literally world gravity. Yeah, I think that's where I fucked up last time. Because that's what I did over here, I think. I think that'll make more sense. Yeah. Alright, so then... okay, so I got previous position here. Oh yeah, my bad. Okay, so this is where the integration happens. So what I'm trying to do is position is equal to previous, or the current position, plus it by the velocity times the delta t. So how would I get the velocity out of momentum and apply that to the position? Or do I just apply... Yeah. So we just shed the mass and then we get the velocity. Okay. Let's see, what do we got going on here? So, physics of velocity. Yeah, so this is how I'm dumping it into velocity here. I'm calculating the velocity based off of acceleration. Acceleration is calculated based off force. Right, so we'll just skip a bunch of that. And we'll go straight to entity position is equal to, well, first of all, let's just get velocity. Just times that by the inverse mass, and they'll give velocity. And then the position is equal to... Oh yeah, my bad. Is that what you mean? Yeah. No, that's... We ain't in C++. Yeah, so... Yeah, but like before this step, we're also adding more to the momentum. So before the update physics, we're doing the pre-physics on the player to add like movement and whatnot. So then we'd be slapping in more momentum in order to actually move it. And I don't really want to times it out by the delta each time, so I'll just do this at the end. And then we go velocity, v2 multiply f32, velocity. What do you mean? Oh, so I have to do it twice, so I would have to multiply the momentum. I don't really know what you mean by that. Okay. Right. Okay. I see. Yeah, gotcha. I see. So then right at the end we go velocity times core delta t. And also, so whenever we add momentum, we really need to multiply by delta t. Or force, yeah. Okay, gotcha. Alright, so then we go velocity times delta t, and that gets added into the position, so that's how we integrate it, and that's a new position. And that seems like that is really it. Don't know what I did here. Scuffed true velocity. Yeah. I honestly have no clue. I think it's actually, it just takes the previous position and the current position and gets the actual change. Oh yeah, my bad. And then the T, 36. Alrighty, and there we will not have anything work. Cool, awesome. Oh yeah, his mass is 0. Yay! Now it's time for collision. Alright, well, so that's really changed things. So I guess we make gravity bigger, IDK. Like, what is this unit? 400. Well, yeah, I don't think I was doing it last time. You see, it didn't though. That's the thing. Like, I've been switching frame rates all the time, and that never affected the world gravity. But it did affect the fact that me applying force on some occasions, like it altered the jump height. So anyway, continue. Right. Yeah, and I think that's what I Yeah, so 2400, that would be, yeah, well. So if we had 60, would that be equal to 1? Yeah, that. Yeah. And that seems like it is the case. Yeah. So this is actually dependent on the mass now. So can we not make it dependent by... Oh, why is it 60 then? Why did I get that 60 value from there? If I make that 600. That now falls a lot slower. Oh no. Yeah, that's what I was thinking. Wait, biomass or by the inverse? No. Gotcha. Yeah, that's what I was thinking. Yeah, because last time, I mean, I think that's how I normalized force. I don't know, I can't remember. But alright, so now if we were to set this to 1, then that would be 1 unit. Kind of like before. Yeah, 1 pixel per second squared. Yep, and then if we set it to, say, something like 100 pixels per second squared, or 98. Yeah. And that is actual world gravity, kind of, maybe, I'd say so. That crack. Yeah. Just gonna put it like 200. That probably feels good. Not really. 400, like literally what it was before. Yeah. That's a good point. Yeah, and that is exactly how it feels. Alright, cool. So, next up, collision. So the way I was doing this before is you would literally just generate collision pairs, and this would give me a whole array of everything that needs to be collided into each other, and then I'd loop over that entire array and one by one generate the manifolds for them and apply them out and do all this kind of fucked massive ass switch statement on every single possible scenario. I mean, yeah, I mean, that's, like, it feels like it's the only way, because, I mean, order definitely matters, you know, like, circle to A, B, B is not the same as AB to circle, so it needs to kind of match that. And then there's some cases where I'm not actually using the library, like down here when I'm doing line collision, I'm doing my own line collision, and it's actually scuffed and not really working, but it works enough, so I kind of kept it in. So yeah, IDK. No. This is This is just getting the manifold, so it gives you the penetration depth and the normal, and then you resolve it outside. So that's kind of how I have it set up, and I don't know if there's a better way of doing that. I can't really think of a better way of doing that. Oh yeah, and then, that's an optimization step. Yeah, right now I'm literally just fucking getting all of them because I don't care about performance. And that'll also play in nicely to the issue I came across the other day with actually trying to figure out how to structure the world data in a right way. But I'll cross that bridge when we come to it. Alrighty. That's a good point. Following. Physics. I don't know. I'm guessing it's pushing to that. Fingers crossed. Lovely. Alright. Sweet. So, I mean, yeah, next step is just putting in the collision stuff. So that would be in this step after we grab all the manifolds. So if we check in the, check in the old physics, I'll show you what's going on. So that was the step we just did with the falling, and then in here we get all the count. I can just copy that over, and then we loop over the entire count. And that's how we would get the manifolds. And then we go, if the manifold count is greater than 0 and the absolute value of the penetration depth is not 0, then we do all this. So this is where the entire impulse resolution step happens. And it's just a lot. I don't know. Why? Oh, this? That's just an initializer to make manifold just 0. So this is just making a manifold. That's right. And then that manifold then gets plugged into the generate collision manifold, and then that actually gets updated with these two collisions here. And that's what actually gives us that collision manifold. And then we come down into here, and yeah, we've got normal, all this kind of stuff. All this kind of yummy, yummy math, which we will redo. But for now, I think I'm literally just going to... yeah, so what I'm doing here is I'm actually giving it the world position, because locally, it's just... the shapes are stored in local space. So they don't have any position in the world yet. So I add the position offset based on the entity's position, and that actually puts it into the world, and then we collide them. And that's how that happens. So I'm just going to copy all that. And that should be relatively decent. Cool. And we clear that. Alrighty. So I guess at this step should have all the data. So the way I can test this is we're literally just going to assert as soon as this becomes a thing, maybe. And that should crash as soon as the player hits the ground. Or not. Cool. Oh, yeah, I think it's being screened now because I have something in here which, screens against the collides. So, back in the player, I actually need to add in the flags for it. So, we're gonna go collide against props, and then set the props to character. And then I also need to figure out where this is. Alright, that's not called that anymore. Physics body properties? What's that called? Yeah, properties. Cool. I'm trying to think, where would the ground be? In entity presets, I would say terrain segment. Here we go. Props, so this collides against so this guy collides against the character and also against items. And there we go. Perfect. Alright, so we've got the collision actually. Oh, fucking hell, that scared the shit out of me. Jesus Christ. I just somehow just accidentally minimized my OBS on the other screen and it just jump scared me. Oh my god. Alright. Cool. Alright, so yeah, that's, we've got the collision. So now the next step is actually, instead of crashing, we resolve it properly and yeah. Okay. Yep, time to step through the math. And I think the tutorial for... no, this is very much the... very much not loading, and it also is very much the... oh no, so we've actually got a thing down here we can kind of copy. Yeah, so we get the relative velocity first, calculate relative velocity in terms of normal direction, so relative velocity dot product against the normal. And we can just really copy this over, because I have this here. Normal, relative velocity along normal. So that's just this right here. Yeah. Now the next question is, how do we're going to need to extract velocity from the momentum, aren't we? So we could probably create a quick little function to deal with this. Quick fast. To get entity velocity. And then we could just basically go like to multiply F32, and that would be momentum by physics dot momentum. Physics dot inverse mass. And that would just give us velocity. We don't need to do anything else. Cool. Okay. Cool. So we've got that. That's that first step. What is up next? So if the velocity along the normal is less than or equal to 0, then we are just going to return. Or does anything happen below this? No. So we can just, I would assume, continue. I'd imagine that applies to the for loop up here and just keeps on going. Right. Gotcha. Yeah, no, this was me. Great concern. Yeah. Yeah. Cool. It's just how I did it down here, because I wrapped that entire thing in one more if statement. Alrighty, so this is where the actual impulse resolution happens. Impulse resolution. Alrighty. So, calculate restitution. Is the minimum restitution between the two. I don't really know what restitution is, but it's something that we defined on the physics body. Yeah. Yeah. Just immediately reflects the momentum velocity. Yeah. Alright. So we've got to put restitution back in. Put that in here. Restitution. Bunch of just fucking nested ifs. Oh, branch instructs, right. I see what you mean by the data. Alright. Alright, hang on a sec. Dogs are being sus. Dogs are trying to like dig out of the house. They're just burrowing. It's quite interesting. Okay. Well, it's 5 o'clock. I actually have to go get ready for Amaze 21st, so I'm gonna have to pick this up another time. What time is it there for you? Jesus. Get to bed, boys. What are you doing staying up, huh? Yeah, I mean, I don't think I'll even, like, I haven't been marking anything, so this isn't even gonna be a video. I did do like a 1 hour stream this morning, which could easily be a video though, so. Just in between the next video, it's gonna be like, hey, we managed to solve this entire thing, crazy. Yeah, so there we go. Exactly. Maximize your work. Alright, well, thank you very much. That's all I wanted to say. Thank you very much. Thank you very much. What were you gonna say? Yep. That's what you want. Alright, boys. Appreciate the help yet again. Absolute lifesavers. I will come back and try and polish this off either tomorrow or the day after, but I will get it done, and I may as well just push this up. I mean, it doesn't really make sense to push half of this up, but I'm just gonna do it anyway. Collision half done. I guess collision is implemented. Collision put in. There we go. Easy. Commit. Alrighty. Well, thank you boys for hanging around and helping me through this. And I will see you in a little bitty. Adios. Oh, alright. Well, again there. Slowly but surely, we will have the very first physics constraint in of a constant velocity across some slopes up until 45 degrees. And then we'd no longer have solid footing, and we'll just fucking do some shit. We'll do some shit, eh? We'll do some shit. Alright, boys. Thank you very much for tuning into this stream. I have no idea how many people are watching, because I stopped the stream, and then I started the stream, and I would imagine a notification probably didn't go out, but it doesn't really matter. All you boys chilling here right now, the OGs, you know? The OGs. You just came in. You just stumbled across it, you know? Alright. Hey, that's me done for the day. Put in some goddamn work. Some actual work, instead of, you know, me showing up for an hour and a half and dipping. Alright. Just ending. That really sucks for you, Artemis Gaming. Bit of a rip. Alright, see you boys. Peace. Take care. Enjoy the rest of your day. And I'll see you next time. Adios.